All right, let's go over scientific notation, this first activity right here. It says do any 12 problems. So there you go. So if we turn the page, and here we go. Scientific notation practice. This is sometimes, most people can get it pretty easy, pretty quickly. Sometimes people have a little bit of trouble at the beginning, but alas, rest assured, it is not very difficult. So what's the point of scientific notation? The point of scientific notation is to make numbers that are really, really big or really, really small manageable when you're doing your calculations, right? So for instance, number 5, that is a very, very small number because the decimal is before a lot of numbers, a lot of zeros, and then you got your 5, 7. It's a tiny number, right? And you don't want to be punching that over and over and over again in the calculator. It's just too much. And then number 1, I believe that's 28 million. That's a big number too. And I'd rather shrink it down, right? So if you want to read your reading material to help you, you can do that. This is just sort of my explanation of how I deal with this and make it manageable, right? So here's what you do. You are going to, the format is going to be like this, right? Number, decimal, number, number, times 10 to the number. Okay, so what does that mean, right? That means you pick your leftmost number. Notice that this one has 3 numbers, right? So let's do number 1. Your leftmost number is 2. Okay? So you know it's going to start with 2 point, and then if there's any numbers after that, you can put those no more than 2 numbers after the decimal. So 2.8. We're not going to worry about the 0. If you want to put 1 0, you can. Number, point, number, number, times 10. You're going to have to count it in a second, but just, I promise you, just start with that format. It'll make these problems go a little faster. So, number, point, number, 2.8 times 10. Now, naturally in number 1, the decimal is always, if you don't see it, it's always at the end, right? So now, we're just going to put the number of times we need to move our decimal back to where it goes back to where it looks normally. It'll make sense in a second. I know it sounds weird, right? So if it's at 2.8, we're going to move it 1, 2, 3, 4, 5, 6, 7. So you should have 2.8 times 10 to the 7. Because in order to put it back into its original form, you'd have to move the decimal 7 times to the right, right? So that's easy. Let's do another. We're going to do a couple random ones on the top, and we'll do a couple random ones on the bottom. So let's do number 3, because number 3 could be a little tricky because it's like, okay, well now our number's way over here, so what do I do, right? So remember, we start with the leftmost number, so I'm just going to write it down. So I got 4.63 times 10. Number, point, number, number. If there was more numbers after this 3, I wouldn't put them because I don't want to put any more than 2, right? Now, the next thing we do is, so we put it 4.63. First of all, how many times would you have to move the decimal to get it back to its original place? So that would be 1, 2, 3, 4, 5, 6, 7. So we know it's going to be 7. Now, because we had to move it to the left to get it back to its original spot, it's going to be negative 7. So you should have 4.63 times 10 to the negative 7. Back to number 1, it's positive because we have to move the decimal to the right to get it back to its original location, right? Whereas here, number 3, we had to move to the left. So that's the only difference, positive, negative. Okay? All right, let's do one more. Let's do number 6. I'm going to straight up roll into it. Number, point, number, number. If you want to do 2.0, you can do that, or you can do 2.01. It's up to you. But remember, we don't do more than 2 numbers after the decimal. Times 10, and now I'll do my thinking. Because I know this is going to be, it's going to look like this at the beginning, so why waste time trying to think and calculate when you just, bam, write it down, right? Now, 1, 2, 3, 4. So 2.01 times 10 to the 4, done. Very easy, right? Very easy stuff. So, that's easy. Hopefully you guys got that. I'm going to do one more. I'll do number 2. I encourage you guys to pause it, do it yourself, and then, unpause it and check it. So here we go. 3.05 times 10 to the 5. 3.05 times 10 to the 5. Easy, right? That's all you got to do. Easy money. All right, so let's go to the bottom. The bottom is also easy. Again, the only difference now is instead of going from our original form to scientific notation, this is called scientific notation, we are going from scientific notation back to our original form. All you do with this is you look at that number, that exponent next to the 10, and you say, okay, how many times do I move the decimal? In this case, it's 5, and in what direction? So, look at the number. Look at how many times. That's how many, even though it's sloppy. And then look at which direction. Easy, right? So, let's do number 9. If you don't want to get it spoiled, pause it. So, 8.54, I'm just going to write that down. 854. And I left some space because I haven't looked at if it's positive or negative or not. Now, because it's positive, that means we're going to the right? So, 1, 2, and then I have 3, 4, 5. So 1, 2, notice these little buckets are filled with a number, right? So we don't do anything there. 3, 4, 5. This 3, 4, 5, I got to fill it with a 0. So 3, 4, 5. Okay? Let's do a couple more. Let's do 12. 5, 9, 7. It's negative, so I'm going to the left 3 times. So it was 5.97. So 1, that's filled. 2, 3. These are empty buckets, fill them with a 0. So the decimal ended here, right? So it's going to be point, the 2 buckets, 1, 2, 5, 9, 7. Easy, right? All right, let's do 16. And this is sort of my method. You're going to start developing the more physics you do, more like of your own personal style of how to do it, because you can do these different ways and you'll have different techniques or whatever. So this is 16. 3, 2, 1. Now it's 10 to the 8. So this is what I do. I count how many times do I have to get to the end, and then whatever number I have left over, I just start adding zeros. Just make it fast. So 321. 1, 2. 8's my final number, right? 1, 2. 3, 4, 5, 6, 7, 8. Bam. That's my style of doing it. You can develop your own. Either way, as long as you get the same answer, you're good. So that's it. Pretty easy, yeah? It's not hard. All you're doing with this page is moving decimals around. The calculator will very often give you these, especially when you use the scientific notation calculator. So just as an FYI, instead of saying times, for instance, times 10 to the 3, it's going to give you a number and it's going to say E3. So this E3 just means times 10 to the 3. So just keep that in mind, because you'll get that in your calculator and you'll be like, well, what is E? Why does it say E? And that just means times 10 to the, right? So there you go. Very easy stuff. If you guys got any questions, let me know. If you want to check them, let me know. We can check them, but once you get it down, once you get a few down, you're going to find that it's very easy. So, all right, guys, let's rock and roll.